Alright, I'm going to be covering angles in this video. Pretty basic stuff, but also pretty important. Like, this is fundamental level maths that you'll use throughout your entire academics. So, before we talk about any units, we first got to define what an angle is. And we got to make sure we don't fall into the Wikipedia trap of defining an angle using the word itself. I mean, this is just tragic. But anyway, I think the easiest definition to understand is the Google's definition, and Google just defines an angle as the space between two intersecting lines. Don't worry about this red part for now, I'll talk about that later. Here's an image to help understand what this definition is really talking about. You can see how this little arc thing is actually the angle, and notice how it matches our definition of what an angle is, as in the space between these two lines. Now, just like how length is measured in centimeters and meters, or if you're really weird, you'll use something like inches, angles are measured with two main units, and those are degrees and radians. If you have one of those fancy scientific calculators, you might have seen a third angle unit called gradians. And I won't be covering gradients in this video, but all you need to know about gradients is that they're completely useless. For maths, at least. Anyway, let's talk about degrees. And a degree is just defined as there being 360 units in a circle, which means that in half a circle, or in a semicircle, there is 180 degrees, which is just 360 halved. And that also means that in a quarter circle, there is 90 degrees. And this is actually how perpendicular lines are defined, when two lines meet and create a 90-degree angle. Notice how as the degrees increase, the space between the two lines also increases, and this matches our definition of what an angle is earlier. So why are there 360 degrees in a circle? Well, to be honest with you, no one really knows. There are some theories behind why 360 was picked. For example, back in the day, like way back in the day, back when color hadn't been invented yet, ancient astronomers used to look up at the sky and they realized that the Earth revolved around the sun, and it took roughly 360 days for it to revolve around the sun once. So maybe that's where they got 360 from. I don't know. But they were also wrong. There's actually 365 days in a year. What a bunch of bozos. Anyway, I think the most convincing reason, though, as to why 360 was picked was because 360 is just a nice number to deal with. For example, these are all the numbers that you can divide 360 by. But if you compare it to another number like 100, for example, 360 is actually better if you're thinking about how many numbers you can divide it by. Before we talk about radians, I think it's important to know the names of a couple of these angles. So, an acute angle is less than 90 degrees, a right angle is equal to 90 degrees, an obtuse angle is greater than 90 and less than 180 degrees, a straight angle is just 180 degrees, a reflex angle is greater than 180 and less than 360, and a complete angle is equal to 360 degrees. Notice how they're all in degrees, so if you were using a different angle unit, then these numbers here would all be different. Anyway, let's talk about radians now. One radian is defined to be the angle in which its arc length is equal to its radius. So if we think back to the circumference of a circle, the circumference of a circle is equal to 2 pi r, which means that in a full circle, there are actually 2 pi radians. And because there's also 360 degrees in a circle, we can say that 2 pi radians are actually equal to 360 degrees, which means that pi radians are equal to 180 degrees. And if we want to convert from degrees to radians, we multiply by pi over 180. And if we want to convert from radians to degrees, we multiply by 180 over pi. So why do we have both? Why is there a need for both degrees and radians? Well, if we think about degrees first, degrees are an arbitrary scale, which is a good thing because we can pick a nice number for it. So in this case, we picked 360, and 360 is a nice, easy number to deal with because of how many divisors it has. This is also a reason why degrees are introduced so early in academics, and it's also a reason why degrees can be easily visualized. And what I mean by that is, if someone asked me to quickly sketch 120 degrees, I think I would be able to sketch 120 degrees pretty easily. I know that it's greater than 90 degrees but less than 180, so I would draw something similar to this. But if someone asked me to sketch 2.944 radians, uh, I don't think I would be able to do that as easily, even though they are literally the same angle. Radians, on the other hand, are more natural than degrees. They use part of the circle as their definition instead of arbitrarily picking a number, which is also why radians are used more than degrees in higher level maths, and is also a reason why radians are introduced later. And lastly, in radians, we get pi, which is kind of cool, so that's why we use radians.